Okay, welcome to Physics for Today. I'm going to be doing a couple of problems from the Giancoli textbook for you, Chapter 7. Problems that were assigned over the week so far. Problem 3, I'm going to do problem 3 first. Problem 3 involves figuring out how much force is generated, force exerted on a rocket, given that the propelling gases are expelled at a rate of 1,300 kilograms per second, with a speed of 40,000 meters per second at the moment of takeoff. So what we can do here is we can determine the amount of momentum gained by 1,300 kilograms of gas. Right? So the momentum gained by 1,300 kilograms of gas expelled at 40,000 meters per second is 5.2 times 10 to the 7th kilogram meter per second. Now, we're gaining this much momentum per second because we're expelling that much gas per second. If we wanted to write this as delta P equals J equals Ft, we're looking for the force, right? We want to know how much force is generated here. The gas molecules of this 1,300 kilograms of gas is going from rest to 40,000 meters per second, so the impulse is this for that 1,300 kilograms of gas. So 5.2 times 10 to the 7th kilogram meter per second is equal to F times 1 second. So the force is simply 5.2 times 10 to the 7th kilogram meter per second, which is a Newton. So 5.2 times 10 to the 7th newtons. So the other problem that was assigned on Monday night was problem number 8. And in problem number 8, we have a 15-gram bullet being fired at some unknown velocity into a block that's 1.1 kilograms, and then the block slides across a surface for 9.5 meters before coming to a stop. And we know the coefficient of friction along the surface is 0.25. And what they really want to know, what they're asking us to find, is what is this velocity that the bullet had before it hit the block. Well, what we have to do is understand this is an inelastic collision, or a totally inelastic collision, so the bullet and the block become a single object and they slide off together for 9.5 meters before coming to a stop. So we could say m1 v1 plus m2 v2 equals m1 plus m2 times v prime, where this is the velocity of the bullet and block as they're sliding together across the floor. Now the block starts from rest, so we could eliminate this first term, and now we could say 15 grams, that's 0.015 kilogram times v1, this is the velocity of the bullet before it hit, is equal to the sum of the two masses, 1.115 kilogram times v prime. So in order to get v1, we're going to have to know v prime. That's the velocity that the block had when the bullet initially hit it and it started to slide. So we can use a variety of different methods to get that velocity. You could use the timeless equation and some kinematics, but in order to do that you have to first determine the acceleration, which wouldn't be too hard. The acceleration would depend on the net force, and the net force depends on the friction force, since that is the only force acting on the object. I'm just going to use energy because it seems a lot simpler to me to do that. So final kinetic energy is equal to initial kinetic energy plus conservative work plus non-conservative work. Of course, there's no springs and no gravitational influences here. And the final kinetic energy when it stops is 0. So 0 equals 1/2 mv squared plus, and now the only non-conservative work here is done by friction, so friction force times the distance. 1/2 mv squared is equal to mu mg times d. You see our mass really doesn't matter here. So the velocity is what we were looking for, right? The initial velocity of the block and bullet together. So 1/2 v squared is equal to 0.25 times 10 meter per second squared times 9.5 meters. So v is equal to the square root of 2 times 0.25 times 10 times 9.5. And this velocity is 6.9 meters per second. So knowing that that velocity was 6.9 meters per second, this is the v prime back here in this equation, we can say 0.015 kilograms is equal to times v prime, v1 is equal to 1.115 kilograms times 6.9 meters per second. And we solve this for v1, so the initial velocity of the bullet had to be 513 meters per second.